here and see all the logical partitions or virtual machines as they're known. As we don't need this list over here, we can pop this out of the way, give ourselves some more pixels. And let's open up our two biggest machines here, Ruby. In the previous movie we quickly started a few LPARs just to show. This one failed to start. That's because this virtual machine here was relying on two VO servers that I hadn't started. If I click on here and look in Virtual Adapters SCSI, you can see here it is using two disks on the VO server 3 and 4. And they were here and I hadn't started them, so it could never start up this particular LPAR. This one is actually using a cache disk, so it's using the AIX Flash cache feature to give you a massive turbo boost to my local disks in here. The other one in here that wouldn't start was 34, and that turned out to be my mistake. The boot disk wasn't set properly, and I've made a note in here that this is Rail 7.1. You can see here and Red Hat puts Linux BPC 64 in it. Some of the other operating systems do different things in here. These things are all for the computers rather than the LPARs. There's a bunch more down in here you might want to have a look at, investigate as well. Okay, we have a bunch more columns in here. So over here we can see we have copies of things like AIX 7.2. In here, this is a SUSE Linux, and the details of giving it is about the kernel level. I didn't see that's particularly useful in here. On the Red Hat ones it says unknown. I haven't added the packages to pass that information back. If we go in here you can see I've got a whole bunch of different copies of AIX. Actually I've got a copy of AIX 5.3 running on this Power 8 machine. I better not tell you any more about that. In here we can see the various levels of the VO server. Oh, notice one in here. There's a 1 missing here. That should be a 1, so that needs an upgrade. To get around to that after finishing my movie. Okay, so let's take this guy in here, and this movie really is about everything we can see in here, the properties onwards, and as we saw last time, we click on here, slightly on the screen, tasks, and we get the same list in here. You can choose which way you do that, or indeed you can click here and you get a little menu up here and see the same sort of things. So we have the operations. This one takes up a lot of screen, so unless you've got a massively big screen, probably won't go for that one. Tend to go for this unless, as I said before, if this is right over here, you can't see the button, well you can reach the task up here. So in here, let's have a look at some of the things in here, and I'm going to comment on the ones we tend to use a lot. I'll dodge a few of them that aren't so popular in my experience. So let me go back. Okay, so this is the properties of a virtual machine, and if you like, we set up a lot of these when we do a create. I'll probably do that in the next movie. So here we have, we can perform the collection of information about this. This means the HMC can show more information there and collect performance stats. Tend not to use these two. If you're in a highly secure environment, then you may have gone for the trusted platform. That checks that people haven't altered the boot disks or the boot disk contents and things like that. And some people like the suspend, where we can halt the CPU, remember where it was, and start it again from the same instruction that it stopped at. side, I'll just grow this a bit, we have the processing units. This number in the middle, of course, is the entitlement that we tend to talk about more than processing units. We have the minimum maximums. These are the range where you can slide the actual current entitlement between these two by doing dynamic LPAR changes. And we have the weight factor example uncapped, so we know that this one can go up to 4 CPUs, even though it's only entitled to the 3 CPUs is guaranteed to it. I'm not using on this machine now pools, so that's in the default pool, and we're in Power 8 mode on a Power 8 machine. On the memory side, similar sort of things. It's got dedicated memory. We're not using the AMS in here, so it's got 16 gig, and I can't actually put any more in. That's it, because of the maximums already set. The huge memory tends to be used by the high performance guys. Maybe some of the database guys might do that. And at the moment, I've got active memory expansion is switched off. On the I/O side, this is why I've selected this particular one. This LPAR does actually have physical adapters. These are 2 RAID controllers inside the machine. So this one's using solid state drives, but normally that's not the case. Most of my LPARs or VMs have no physical adapters, they're all in VO servers. Here's our link to the virtual adapters that go off to the virtual I/O server. You can see here's the Ruby 3 and 4. These two are used for the console sort of dumb technologies, so you can get in if the network's not running or you haven't set it up yet. And we have a virtual network that is connected to the VO servers as well. Now these 2 connections are giving dual path access to the same disk on the 2 different VO servers. Don't think we got any SRIOV in here. Again, that's probably a different movie. And I forget what's in the settings, to be honest. Yep, just normal things and other. Particularly exciting in there. Okay, let's continue down our list in here. Come back to that one in a minute. Shut down and restart. They're much the same. The restart will just stop the operating system and then bring the operating system back up. It doesn't actually stop the LPAR, so if you make changes to your configuration in here, that won't actually get picked up. Let's have a look at shutdown. It does it all the way down. Actually releases all the resources for the virtual machine. Let's drag that back up. We've got different things we can actually do in here. Immediate shutdown means stop the LPAR and it just halts the processor, so no flushing your disks. If you're in open firmware and it's got stuck booting up, that's fine, but otherwise not recommended if you've got an operating system down here. We've got shut down the operating system, which tells the operating system to do its normal shutdown procedure. It does wait, I think it's 5 minutes, so if you've got the time that's okay, and it does a wall operation and wants any logged in users at a shell prompt. That doesn't help your applications, of course. If you do a shutdown immediate, then it doesn't give the 5-minute warning, it just does a regular shutdown as if you typed in the command. Telling it not to hang about or give things any time. Both of those will do an orderly shutdown of your applications. You don't want the applications going down and let them tidy up. Nobody seems to use the delayed power off sequence as far as I'm aware. Won't do that because I actually want my machine running to try other things. Okay, next operation down in here, deactivate LEDs. We actually haven't got an LED against this LPAR. If this was an operating system that was reporting errors, like you had a disk drive on a adapter and the adapter failed or something, then we'll have a look at looking at those service events and clearing things down. Of course, just switching off the LED doesn't actually get rid of the error, just get rid of the annoying Glarus triangles that we can see hanging about the screen. Next we've got scheduled operations. Those are pretty cool actually, and we don't tend to use them here. In production, I think we would. Let's create a new one. We can do things like activate an LPAR or shut one down. So we may have an LPAR that only works at the weekends, for example, to use some spare resources. That would work. Or we could do a dynamic reconfiguration. Take CPUs out of a virtual machine and put them back in, perhaps for Monday morning or something. Let's just use that one as an example. It says when you actually want to do that. That's actually 6 o'clock this morning, so that doesn't help very much. And if you say put in 5 extra CPUs into your virtual machine and there's no 5 available, this window in here will keep retrying for like the next 60 minutes, and as soon as the CPUs arrive freed up, then it'll actually put it into your LPAR. So that's a pretty good way of operating. In here you can say, look, do this every Saturday and Sunday, for example. Click on here and then we can select which days of the week we actually want to do this operation, and how many times we want to do it, or you can say, look, let's just do this forever, this is what we want you to always do. And in the options in here, this is for dynamic resources, so we could say processor, add, and then down in here we say how many extra things we want to add to the configuration. And then it will go off and do this forever, and it will appear on that initial list, and we can manage them and switch them off if we want to do later on. Next up down in here in operations is mobility. Now, we've had lots of movies about this feature, and we can do migrate, slide partition mobility, validate, or recover if it's got stuck while it's trying to do that operation. I'm not going to show you the details in here. I tend to go into evaluate because that does a check to see if it's going to work or not. This LPAR has 2 RAID adapters, so we can't do the line partition mobility, but we can show you a failure. Let's go to the other Power 8 machine in here. We can, if the machine is actually connected to a different HMC, actually put the remote HMC and how to log into the other HMC in here. We'll just do a quick validation here. It should say there's ghastly errors in here because it's using physical slots for exactly the right reason. Okay. Again, that's probably more of another movie to actually show you the details. But if you're pure virtual networks, disks, and DVDs, then you should be able to do live partition mobility. Down here are the suspend operations. I don't tend to use these, so I won't demonstrate that. Configuration, this is a big important thing. These profiles is what you, or the initial profile is what you create when you create your virtual machine for the first time. So if we click on here, this one, that's why I chose it, actually has a bunch of profiles. We can see the active profile up in here, normal with internal SSD, that's the one we last activated. If I started the LPAR and didn't select that, then this would be the normally selected one in here. But if we just click on one of these profiles, it will bring up the details of it, and this looks pretty much like we were looking at the properties, weren't we? The properties of a particular LPAR in here. This is where they're actually getting set when we start the LPAR up. And we've got the similar sorts of details in here. They're laid out slightly differently. We have the I/O, for example. In here, this is like the entire machine. We can see these 2 RAID controllers are the only required ones in here. The rest of the virtual adapters, so the disks that we're booting off, are coming in over here from the 2 VO servers we use in the virtual network. If you want to change this default profile, it's a bit annoying. You can go in here and say, look, I want to change the default to this one, and then you're thinking, well, how do I do that? Oh, this is one if we've done lots of dynamic changes to our logical partition. We actually want to save that in a new profile. That's how we do that. But if we want to change from the default to the last, this one up in here, the normal with internal SSDs, a little bit confusing. That's the one up in here, so we can change the default. Confuse the dickens out of me for the first time. It knows it's on the default, the other 2 I could change to. Let's actually just do that so I don't get confused if I want to boot it up later on. Okay, that's operations, manage profiles. I don't tend to use the other 2, that's similar to what we just done at a lower level. We've seen already these adapters, see the configuration nicely explained. Dynamic partitioning, pretty important in here. CPUs and memory work much the same, sort of different resources, but operate much the same way. The physical adapters we can pull into the logical partition. This is dynamic, so it's while it's running we can do these operations. And we can do virtual adapters, so we can create a new virtual adapter to the virtual I/O servers inside the machine and do that. SRIOV, big subject, we'll cover that some other time, but if we quickly look at probably the most common one you actually want to do is the processors. Okay, so at the moment we've got 3 processing units and 4 CPUs that we're allowed to spread across. We're guaranteed 3 out of the 4 we can actually see. You can see here the maximums are 4 to 4, so I can't go any higher in this. I can take it down a bit. I can take this down, take this to 2.5 guaranteed CPU. The weight factor, I could increase that. If we're making drastic changes with memory, then we actually want to give it a bit more time. Taking memory out of now, I have to make it all out. 64 gigabytes of memory base. Similar sorts of things happen. In the box, and if they're not assigned, then we can put them in. Give it an empty slot, that's really useful. Now there's some resources in here. That would arrive, the operating system doesn't know about that. On AIX, you can check this fine. Right, so we've covered those Windows console terminals. We can use this open to window in here to get a full machine. It's really helpful because if you haven't got the network working properly, different browsers these or they don't work. You've got Vita particularly painful to use, and I don't recommend it to anyone. What we tend to use is cutting via the HMC together console. Okay, so here's Vita. You may have your own implementation software for security reasons and things. Okay, so let's put passwords. Fine. Can I go? Use this thing called BT menu. This is the list of machines. So if we're on a Ruby machine, and here it is, 12. 12. Let's put this on partitions in here, and 6 is here. Hit 9. And here we go. That's the double console. Get it? We need to use this for the message of the day. It's actually Linux. This will, if you're doing initial install, bring us an initial installation options, and we can go through and install that. Okay. What else have we got? Serviceability. Again, we'll have a different way of doing that. I mean, for particular machines with particular help. Service. I didn't cover it exactly the same. I run them as a little cluster using PowerVC. But anyway, I've clicked on this item in here, and you see these little buttons popped up in here. We click on here and do operations power on. We get a pop-up in here. We can hardware discovery is just using. I've got a problem with the root sequence and things. Can't say I use that normally, so we're just doing OK. We'll see here over a reference code. In the good old days, back into the Power 3, we used to have LEDs on the front of the machine, and the codes as they boot it up to tell you what's going on. You can see it's just changed. Yeah, that's no good in a lights off HMC controller computer, so they're actually put on the screen in here. If I deselect that one and select another one, we can do a different one. We've still got a button here. I could go to tasks and operations and power on. That's another way of doing it. You have to decide which works best for you. And so that one should be up in a second. Oh, I just noticed we've got a warning here. Something is amiss. Look at 3 and part 4 that we get. It's a service list and dive in and have a look. Let's start the next one up here. This is orange. Down here we've got a little arrow. If I click on here, we get another little panel in here. Look at operations with some power on down here as well. You'll have to decide what to use for you. I don't like this one because it's taking up a lot of real estate. So we'll pop that one out of the way. Task on the little button is good. If this is slid over so you can't see the button from the end, then that's because there was a little bit here. Okay, so these are initializing. You can see here available